Hello everybody, so today I will explain this question. Count non-decreasing subarrays after k operations. Okay, so I will explain what this question is. So in this question, I'm given an array nums and an integer k. I'm given something like this. And my task is to So my task is to count the number of subarrays which meets some condition. So the condition is that with up to k operations, I can make that subarray into non-decreasing one. So for example, let's say I'm given k is 1 and I'm given something like this. In that case, this subarray is valid because after one operation, I can make it this. So I can increment this 1 into 2. So now this 2 to 3 array is non-decreasing. So I can say when k is equal to 1, this 213 is valid. So in this question, I'm given k and given subarray, and I will count how many number of subarrays can meet the condition. So for example, this case, 631. In this case, I can make this array into this with cost 3 plus 5 is 8. 8 is larger than k, so this is not valid. But for 63, I can make this subarray into 66 with cost 6 minus 3 is 3. So this one is valid. And my task is to find the number of valid subarrays in the given array. Okay, so for example, this case, here I can see out of all 21 subarrays nums, only the subarray is 631. Yeah, this cannot be made non-decreasing after applying up to k operations. So the number of non-decreasing subarray is 21 minus 4 is 17. So I written 17. Okay, so that's the explanation of this question. Okay, so now I will explain how I can solve this question. So the thing is, I use the sliding window. So I move left pointer and right pointer. But in this question, I should start from the tail. So how it works is, I move the left pointer, then I shrink the sliding window until the window becomes valid. So in this case, this is valid, so I don't have to shrink. And I move the left pointer, yes. In this case, still valid. So let me change numbers a little bit. So let's say this is 0, and the cost should be at 3. In this case here, oh, that's good. Let's make it 7. So here, 744, to make this subarray valid, I need 3 plus 3 is 6 cost, which is more than 3k. So I have to shrink. And when I shrink here, this is now valid. 74 is valid because I need only 3 cost to make this into a non-decreasing subarray 77. So this is valid. And when this is valid, this one is also valid. So I can move the right pointer until it reaches left pointer. Yeah. And if I move this left pointer to here, in this case, this is still valid because I need 3 cost here. This 4 should become 7 and it becomes valid. And when I move left pointer to here, now what happens is that this one has to become 3. It takes 2 cost. And this 4 should become 7, which takes cost 3. So in total, it takes 2 plus 3 is 5 cost. So this isn't valid. So I have to shrink. And when I shrink into here, it takes only cost 2 to make this non-decreasing. So this is valid. And once I can say this is valid, this is also valid, and this is also valid. So that's the thing. One more example. If I move the left pointer to here, right pointer should start from here, because if I move it to, rightward, it becomes invalid. Because this one is invalid, and adding this number doesn't help. So I should start from here. And if I start from here I need 3 plus 5 is cost 8. I need cost 8 to make this non-decreasing. So I shrink right pointer here. Not enough. Here, this is enough. 6, 6. Yeah, I can make this 6, 3 into 6, 6, which is non-decreasing with cost 3. It's okay. So in the end, I can say 1 plus 2 plus 2. So this is a number element from left to right. And 3 and 3 and 2. So in total, I need 13. I have 13 subarrays, which means the condition. So this is, in this way, I explain why I can use the sliding window here and how I can use it. Okay, so now I implement this. I move the left pointer and the right pointer. So here I move the left pointer, and I need the window here. I just keep track of the numbers in this window. I actually don't have to do this, but in the optimization I will make later, I use some data structure here. So I put the numbers into window here. Yeah, let's call it Q. The Q is exactly the numbers in the current window. So I move the left pointer. And when I move the left pointer, this number should be pushed into the queue. Yep. And here, after moving the left pointer, I have to shrink the right pointer until this subarray becomes valid. So the condition I have to shrink is obviously the cost is more than k. I can say it in this way. If this cost is more than k, I have to move the right pointer. And also I have to pop out the number from the queue. And here, I find the left right, which is valid. So this is the longest valid subarray with left pointer fixed. So number of valid subarray with current to left is right minus left plus 1. Like I calculated here. Okay. So because I need to return the total number, I increment read and I return read in the end. Okay, and now I increment the calculate cost method. So what I want to calculate is, let's say, the array looks like this. In this case, I can make it in this way. Yep. So I should return 1 plus 3 is 4. So I can make it in this way. So I keep track of the current number. So it should start from, let's start from minus infinity. And I take a look at each number. And this is num1. And I compare with the current. And because this num is larger than the current, versus the previous number, I don't have to make any operation on this one. I keep going, but I update the prev with this num in this way. But now here, prev is 1 and current number is 0. I have to increment this by 1. So cost here is prev minus num. But if this is needed, if current number is smaller than previous number, I need this cost. So let's say read is the total cost. In that case, I have to increment this return total cost with prev minus num. And then I update the prev with this number. Okay. And I return this read in the end. Okay, now let me execute my code because I'm done with the implementation. Accepted, but yeah, this is actually TLE, time limit exceeded solution. So let me tell you why. So in this operation, obviously, for each left pointer, I do this calculate cost method. So left pointer takes n steps, assuming that there are n elements in the given nums array. For each step, I code this, and this queue can be up to ranks n, and I do the linear scan on this queue array. So in total, it takes n times n is n squared. And n squared time complexity is not allowed, accepted in this question because of this constraint. So I will try to optimize this for, hopefully n log n time, or maybe O of n time. Okay, so when I look back this solution, something which takes the time is calculating this cost. So how can I optimize this? So in this case, let's say here, it ends up with Q. After at this moment, Q is 174. And here, I firstly add 3 to this Q. Three is added here. Then this becomes like this. and I calculate the cost. But the thing is, how should I say? So when I add this 3, this array looks like this queue looks like this, and I have to amend this to 3, 3, 7, 7. So the thing is, once I update this subarray into this, 174 to 377 with cost 5, I never revert this 7 because how many numbers I add from the head, it doesn't help this 7 to decrease. If I add, say, if I add one more 5, I have to increment this 3 and 3 to 5 and 5. But obviously, this 7 doesn't change. If I add some small number like 1, no one changes in this array. And obviously, this 7 cannot go back to 4. So once I update the queue, the observation is that once updated the numbers in the queue, I should never roll it back. And also, it will be pushed out in the future, but until then, this number never goes back. So that's what I found from this observation. So that being said, what I can do is I update the queue, and also I can keep track of the cost I had to apply in each element. So queue should now look like this. And I can keep track of the cost as a single variable. In that way, I don't have to traverse the queue to calculate the total cost. So, I can calculate the cost in this way. Some of the gaps, but I keep track of this. So that I don't have to traverse nums. Okay. So let me update the implementation with this idea. Okay. So here I keep track of this. So when I append this number here, before appending this number, I have to update the queue. So in this way. So because with this, idea, now numbers in the queue should look like this. Originally, maybe it was 744, but for this number 4, this should be updated to 7 to make this 744 array valid. and this one too. So let me change it, the order. Originally, it should be 4 and 7, updated to 7. Yep. So originally it was 744, but it should be updated to 777 to make this non-decreasing. Okay. So what I can do here is, let's say I have some number like 8 here. In this case, this should be updated to 8 and 8 and 8. And the observation I can make here is this array is increasing. Let's say this was 8. In that case, this should be 8. Yeah, like this. So I don't have to take a look at until the end. If 8 is given, sorry, I have to update the number until updated bar is less than this 8. Okay, so what I can do is I take a look at each I here, and I guess the updated bar. In this way. And if this is smaller than current nums left, new number, I update the updated bar to nums left. Yep. And again, as I said, this queue dot updated bar is increasing. I have to iterate until this updated bar is equal to nums left, or if this one is larger than nums left. So I mean, if this is larger or equal to nums left, new number, I can break. Otherwise, I have to update. And also, as I said, oh, no, wait. And here in line 42, instead of calculating the cost every time, I keep track of the cost. And this is actually the sum of updated bar minus original bar in the queue. So I keep track of this cost. So this cost should be updated here when I update the number in the queue in this way. Okay, so I could update the cost. And now here in line 34, if this cost is larger, I increment the right. Sorry, I move the right pointer to the leftward, and also I pop out something from the queue, and I can say the cost of the last number in the queue. So when this looks like this, let's say it looks like this. If I pop out this element, I can say for this element, the cost which was taken for this element was 9 minus 5 is 4. So this 4 should be subtracted. I mean, I should subtract this cost 4 from the total cost. So let me rename this to total cost. And here, I decrement in this way. Maybe I can write it in this way. So I pop out something and I subtract element. Oh, no, sorry. Sure, this isn't the cost. Original bar and updated bar. So I should so this is the cost I took for the last element in the queue. So I have to add this to total cost. So total cost is, total cost decreases. I move the right pointer and I have to move the right pointer until total cost is less than or equal to k. Okay, so this is it. Now I don't need this calculate cost method. And I submit this solution. No, this should be Q. Oh, and here, when I append this number, original number is equal to update number when I first push it. Obviously, because if, I append some number to the head, and if this number is very big, I have to update these numbers. If this number is small, I don't have to update anything in the queue. So what I want to say is the numbers in the queue is adjusted by this new number. So this new number shouldn't be updated first. So updated number is equal to original number first. Okay, let me submit. I see. So this should be list, not tuple, because I have to update it later. So let me debug what's wrong with this. Okay, so firstly, it pushes 4.4 and 4.4 and 4.4, yes. And let me type cost here. Okay, so here total cost is 0, yes. 0, yes, yes. 2, 4. When I push 2 to here to this queue, it's fine. 244 is buried, so I don't need any cost to update this queue. But and when I add 1 through the same, and next when I find new number 3, 3 should come first, and I have to adjust this 1 and 2 to 3. This becomes 3 and 3, yes. And total cost is, oh, this should be 3. So what's the problem here? Here. So this one, Q1, I1, should be updated to nums left. So the cost I need is nums left minus Q I1. Okay, good. So that's something. So I don't need this method anymore. So I delete it. And now let me submit. Actually, this is still TRV, so I have to make another optimization. Yeah, so I will explain that. So when I take a look at this implementation, there is a for loop for the left pointer, and there is a nested loop for this queue, and also another loop for right pointer. And actually, this right pointer movement is fine because right pointer's position is not reset after I move the left pointer. So even though even though this while loop is inside of the for loop, this right pointer moves independently from left pointer. So for this for loop and for this while loop, it takes only the O(n) time because left pointer moves from tail to head, and right pointer moves from tail to head independently. But for this one, actually this is the problem. So I take a look at queue, element in the queue, every time I move the left pointer. And this queue actually can take O(n) elements. So it could take O(n) time complexity for this inner for loop. And I iterate this n steps. So in total, it takes O(n) squared time complexity. Actually, even though introduce the total cost and also this tuple concept into the queue, even though, despite this implementation, despite this optimization, the time complexity is still O(n) squared. But with one more optimization, I can make it O(n). So I will explain what it is. Okay, so before making the second optimization, let me update something in my implementation here. So let me delete original var from this queue because it isn't necessary. And actually I can delete it. So when I delete this, and I push only the updated var into the queue. So with this in my mind, this is actually don't need it. This is not necessary, so I delete it. This should be deleted. This should be deleted. And here I should append only nums left. And I can get only the updated var from q.pop. So how can I get this original var? So this is easy. So let's say the array looks like this, and I'm moving the right pointer in this way. So when I pop out something from the queue, this is the updated var, and I need the original var. I see. So when I move the right pointer from here to here, I pop out something from queue. And actually this queue was originally this one before moving this right pointer. So I move the right pointer, and because right pointer is moved, it means that something should be popped out from the queue. So I popped out something, so which is this updated var. And obviously the original var of this value is this. So what I can do is before moving this right pointer, so let me move this to here. This updated var is, this original var is exactly nums right. Yeah. And after taking this, I move the right pointer. So now updated var is not needed. Let me move this q.pop to here. And this is it. Okay. So let me check if this still works. Good. It's working. Okay. So I've updated something here. So now I will tell you what I can do to optimize this solution more. Okay, so here I'm popping out element from the queue if it is smaller than new number. So this queue is now completely increasing monotonic queue like this. And I'm popping out, if this is 8, I'm updating this to 8 and 8. Then I append this 8 to queue. So instead of this, let's think I count the number here. So like this. Here I have 2 7s. I have only 1 8, and I have 2 9s. So with this idea, if I have 8, I have to update this to 8, and I need plus 2 cost. Then I add this to, I add this one to a top of the queue. So this should be 2 plus 1. So I take a look at the top number, the first number in the queue, and update the cost, update the bar, and keep track of the cost for that. And also, I increment this count by 1 because I add exactly that number to this queue. So this is how it works. And let's say a bit more interesting case like this. In this case, I have actually 2 6, wait a minute, 1 7, and 2 9s. In this case, if I have to add 8 to here, firstly, what I can do is I update this to 8, and I do plus 2. Oh, wait, what was it? Sorry. Oh, this was originally 6, so I do 2 times 2. Yeah. And now, this is 8, so I add this 8 to here, and it looks like this. I have 3 8 and 1 7, and I compare this and this. Now I can say this 7 should be updated with 2 8 like this. I need 1 cost. And now I can merge this and this. What happens is 8 4 and 9 2. So what I can tell is each element is popped out only once, and after that it is merged into the new number. So I can say I add new number to this queue every time I move the left pointer, but every time I move the left pointer, I pop out some element from the queue and merge them into the single element which has the bar which is equal to the new number. So I can say each number added is popped out at max once, because if there is a number which is larger than that number, I pop out some numbers, elements from the queue and merge them into a new number and add. So number of times new element is added is exactly n times. And the number of times each element is popped out is up to 1. Because after it is popped out, it is merged into the new numbers count. And these element before. So I can say this takes only the constant time. So let me use this idea to optimize my solution. Yep. So this is my second optimization in this question. Okay, so what I can do is here I need updated bar and count. And here, if this number as the head is larger than the new number, I pop it out. Okay, so let's say here is the new element. This is updated bar and count. So this should be added in the end to the queue. So every time I take a look at the head of the queue, I delete this. If there is an element in the queue, and the top element, updated bar, is smaller than new element, or I should say, yeah, nums left. Oh, let me update it. So nums left count. This should start with 1. Okay. So if this is true, I should pop out the head element from the queue. And what I get is updated bar and updated count here. And I should increment the nums left count with this count. So wait, Q01. So this should be Q00. Because I have to take a look at updated bar. So this is the updated bar. If it is smaller than nums left, I should pop it out. And this count should be added to the nums left count. Like this. So I can write it in this way. Yeah. So I keep doing it until this queue, the first element in the queue, the updated bar of the first element in the queue is larger than or equal to the nums left. Okay, so I keep doing it. And after that, I append this element, nums left, to the queue as a head. And also I have to take care that if I do this, I have to update the, score too. So I actually, let me revert my implementation. And here, updated bar. So I should increment the total cost with nums left minus updated bar. Okay. So in this way, Q is updated and total cost is incremented. Okay. Next, here, after popping this out, so I have to take a look at, okay. Here, what is popped out is updated bar and count. So I have to, decrease the count with like this. Updated bar minus nums left. This is nums right, which is the original bar. So this is the gap between updated bar and original bar times count, because I have that number count. Yeah. Okay. The number, that element is count. And then I move the right pointer. Okay, so this is it. Let me submit. Oh, and one more thing I forgot to do is, wait a minute. Looks good. Oh, no, I don't need this iterator. So it doesn't work. Let me debug. So when left is at 5, no element. When it is 4, it has 1, 4, and cost is 0. If I'm left is at here, it has 2 elements and total cost is 0. And when it is at 2, index 2 here, it has 2, 4, 4. Wait. So this 4 and 4, 1 should be merged together, hopefully. But it's okay, I think. It doesn't change the time complexity. So let me keep going. If I add this 3, index 3, which is 2, it becomes like this, and it's fine. And if I add 1, yep, good. And if I add this 3, 3, 3, and 4, 1, 4, 1, yes. And the total cost should be 3, yes, because it should be 2 plus 1 is 3. And after that, what happens here? After that, when I add 6, everything is popped out. Wait, why is it? Because I see. So the problem here is when I move the right pointer by 1, I cannot pop out the whole element. I mean, let's say I move the, let's say I have 9, 2, the tail of the element here. And if I try to pop the last element out, this 2 should be decremented. If I pop out this one, I actually remove 2 numbers from the queue. This is what I want to, this is not what I'd like to do. So instead of doing this, what I should do is, yeah, and actually I'm multiplying by count, but this is obviously not correct because the number of element popped out should be 1 because I moved the right pointer by 1. So what I can do is I decrement the count by 1 and total cost should look like this. Yep. Maybe I should update the total cost first, then decrement the count, and if the last element count becomes 0, I should pop it out. Yeah, so this is what I should do. Okay, let me submit again. Oh, sorry, -1. And oh, I've encountered the same problem here. I should make this to list. Okay, it's almost there. Let me check. So, okay, so when I take a look at this print debugging log, here I can see 4414141. Yes, 214141 until here. it's okay that 1, 2, 4, 4 is here with count 1. And after adding this 3, this and this should be popped out, and 3 should become 3, count 3, and the total cost should be 3. It's fine because I need 1 plus 2. And after that, when I add 6, let me take a look. Before popping out this, it looks like this. So before moving the right, here decks look like this, and I print as the total cost. The total cost is 10. If this is obviously not correct, because if I make everything 6 in this array, it takes 2 plus 5 plus 4 plus 2 plus 2, which is larger than 10. So I take a look at this, and I find that here, I think this is a problem. I have to multiply count on this gap. Now accepted. So let me delete the print statement, and I submit. Okay, now accepted. Great. So I can solve this question in O(n) time in the end. Okay, this is quite a hard question, but let me quickly wrap up. So in this question, I'm given array nums and integer k. So my task is to find the number of subarrays which can be updated to non-decreasing subarray with up to k operations. The first way I implemented this with naive sliding window implementation. I moved the left pointer and right pointer from leftward to rightward. From leftmost position to rightmost. No, I moved left and right pointers backward from the tail. And first thing I did to optimize this is introduce the total count so that I don't have to take a look at the queue. Yeah, every time. And also in my second optimization, I keep track of the count for each element in the queue so that I don't have to update so many elements in the queue. Okay, that being said, I finished my explanation of this question. Thank you for watching. Bye.